All right, next problem. Cancels out. All right, let's go to this first. Remember, quiet down, please. Remember, mole always gets 1. We're going with atomic mass. We always follow this, right? We're going from mole to mass, so if you use atomic mass. Follow me? Okay. Let's go to problem number 3. You try this, and we're going to come back and go over this together. What are we starting with?
Calcium chloride.
We're starting with moles, so we're going to go ahead and start with 1.30 moles. And we write out the formula and we realize that it's CaCl2. So we have to find the mass of calcium, mass of chlorine, but with chlorine's mass we have to multiply by 2, right? Add them together, that gives you 110.98. Okay, so moles cancel out, that's why grams have to be at the top. Okay, now, Taylor, am I going to multiply or divide? I have to multiply because they're next to each other, right? Pretend that it's over a 1. So therefore you have 144.27 grams. How does that make sense?
Wait a minute.
So far we've been going from moles to grams, moles to moles, moles to particles. But this time we're doing volume to moles. Okay, in this particular case, we're talking about specifically this unit called liter. Okay? Now remember that number? How many particles are there for 1 mole?
6.02 times 10 to the 23rd.
Times 10 to the 23rd, right? That's the very first thing we learned. And we said no matter whatever the type of molecules, whatever the type of moles is, we always will have 6.02 times 10 to the 23, right? Okay, it's like that with this too. When you are at what we call STP, in other words, that's standard temperature and pressure, and this is when you have 0 degrees Celsius and it's 1 atmospheric pressure. Okay, don't worry about what atmospheric pressure means to you right now. Okay, all you need to know is that for STP, standard temperature and pressure, you have 0 degrees and 1 atmospheric pressure, 1 atm. And that's not even the important part. The most important part is that when you have 1 mole of gas at STP, you have 22.4 liters. That means it could be 1 mole of oxygen. How much do you think have? 22.4 liters. What if it's 1 mole of carbon dioxide? What's the volume? 22.4 liters. Yes, ma'am.
Hi, can you have Brittany Kilgore come down for early dismissal?
Yes, ma'am.
Thank you.
Okay, what if it's 1 mole of, oops, sorry, let's go back. What if it's 1 mole of hydrogen gas? Okay, everyone say it again. How about with 1 mole of water vapor? 22.4 liters. Okay, really, really important because sometimes you guys are going to look at a problem and say, well, I know that it's at STP, but it's telling me it's this type of gas. And you're going to spend 10 minutes during the test thinking, what do I do with that? That it's the fact that it's oxygen. You do nothing because it doesn't matter. That's what I'm trying to get to you. Okay, so why is this important? Because then we can do this problem. Jabari, read this for me.
The average lung capacity of a male is 6 liters. The average lung capacity of a female is 4.7 liters. Assume the following. Ms. G's lungs are filled completely with oxygen. Ms. G has,
Sorry.
Ms. G has traveled some places where it actually reaches STP, so the gas inside your lungs is at STP. Your favorite teacher is Ms. G.
All right.
These are all in summary.
The number of moles of oxygen in the lungs is my favorite teacher at STP.
Okay, so let's talk about this. Number 2. It says Missy's somewhere where my lungs, her lungs are STP. When you read STP, what is the first thing that pops into your head?
0 degrees.
1 mole is equal to what? Good. That should be the first thing that pops into your head. 1 mole equals 22.4 liters at STP. Right? Now, what are you looking for?
The number of moles.
You're looking for the number of moles. Now, my question is, does it matter that it's oxygen? No. It doesn't matter. Right, exactly. What am I given? I'm female, so I want to go with this one. That every female has 4.7 liters of lung capacity. I want to go to moles. Do I know the conversion from liters to moles?
Yes.
Yeah, so Jacoya, tell me, what is the unit that's going to go at the bottom? Liters. What's the unit that I'm going to have at the top? Moles. Let's fill in the number. What is the number that always go with moles? 1. What is the number at the bottom? 22.4 liters. So you're going to do the math. Are you going to divide or multiply, Taylor? You're going to divide that 4.7 by 22.4. Yes, because of division bar.
You get 0.2098214.
So I do this. Oh, let's clean this up a little bit. And I get 0.2098 moles. Does this make sense?